Namaste, welcome to my channel Educative Youth. Please do like, share and subscribe my channel to get the latest educational videos. Okay. So in the last video I have covered the FCFS scheduling algorithm and non-preemptive SJF scheduling algorithm. And in those videos I have explained in details about the certain important technical terms that you need to learn, that you need to know to understand the concept of the scheduling algorithms. Okay, so if you haven't watched the previous videos, you can just visit my previous videos and learn the important technical terms over there where I have explained in details. Okay, then you can come back to particular video to understand the actual concept of the shortest job first scheduling algorithm. Okay, so in the last video I have explained about the non-preemptive SJF scheduling algorithm. Okay, so in this class I will discuss about the preemptive SJF scheduling algorithm. Okay, preemptive SJF. So I will discuss in details about the preemptive SJF. So those technical terms that is required to understand this particular subject, this particular topic, I am not going in details in those technical terms. Okay, so I will directly discuss the concept of preemptive SJF. Okay, fine. We'll start, right? So here you can see we are having a program that needs to be executed. Okay, so the program is being divided into different processes. Okay, the program has been divided into 5 processes by the operating system, and those 5 processes are residing in your primary memory at present, right now. Okay, so that means they are in the ready state, not running state. They are in ready state. They are in a situation to enter into the processor and get executed in the processor, right? So they are in the primary memory right now. Okay, so you are having the 5 processes P1, P2, P3, P4, 5, P5. Okay, so those 5 processes, their individual execution time. Okay, you can call it as a burst time or execute time. Okay, so what is the execute time of process P1? 6 unit of time. P2 2, P3 8, P4 3 and P5 4. This is the individual execution time of the individual processes. Understanding? Okay. So what is the arrival time of the individual processes? So arrival time, the first process that arrives into the processor, which one? P4 at the 0th time. Then the second process which arrives in the processor is the process P3 at the 1 unit of time. Then third process which arrives into the processor is P1 at the 2 unit of time. Then the fourth process that enters into the processor is process P5 at the 4th unit of time. And the last process that enters into the processor is P2 at the 5th unit of time. Okay, so let's start the SJF scheduling algorithm. So how the SJF scheduling algorithm works, how the preemptive SJF works. Non-preemptive case I have already discussed, right? So today's class I will discuss about the preemptive SJF, right? Okay, fine. This I have got drawn one diagram over here. You just see over here. This is the process. This is the timing. Okay. So right now, which process first acquires the processor? Which process first acquires? The process P4, because it is the first process. The arrival time of process P4 is the first at the 0th time. In the starting, the process P4 enters into the processor and acquires the processor. Okay. First, the process P4 enters into the processor and starts executing. Understood? Next, what is the total execution time of process P4? The total execution time of process P4 is 3 unit of time, or you can say 3 nanosecond. Okay, 3 unit of time. So it starts executing and 3 unit of time to complete its execution, right? It starts its execution at the 0 time. Okay, because P4 has entered into the 0 time. So it starts its execution, right? Next. So P4 enters into the 0 unit of time and it starts its execution, right? Right now, when it is executing 0, then it executing at 1. When P4 is executing and completes the 1 unit of time, it takes 3 unit of time, right? So when it completes 1 unit of time, another process enters into the processor, right? At the 1 unit of time. So P3 enters into the processor and the CPU scheduler just schedules the P3 in a waiting state. Okay? So P3. So here, try to understand. Now the SJF, shortest job first scheduling algorithm gets implemented, right? Right now, as it is a preemptive, okay? So it is a preemptive, okay? Try to understand. So P4, which is already executing in the processor, and P3 arrives at the 1 unit of time. Right now, this P3 and P4, the time of the shortest job will be compared. Which one is the shortest job? Will be compared, right? When P3 enters, P4 has already completed 1 unit of time. Remaining unit of time is P4, 2 units is remaining, still to complete its execution. So at this particular point, P3 enters. So what is the P3 total execution time? 8 unit. 8 unit of time. So which one is the shortest job right now? Still 2 units is left out. P4. P3 is 8 units. So P4 is the shortest one. So right now P4 will not be printed out. It will be executing as usual, right? So P4 start execution. It enters into it starts executing and it tries to complete its execution. Okay. At 2 unit of time, any other process is entering into the processor? Yes. At the 2 unit of time, P1 is entering into the processor. Okay. So see, whichever the processes are entering into the processor, they are kept in the waiting state. They are kept in the waiting state. Okay. So right now, how many processes are in waiting state right now? At 2 unit of time, P3 and P1 are in the waiting state. Right? P1 enters at the 2 unit of time. Right now, when P1 enters into the processor, right now the SJF, shortest job, will be implemented. Now, P4, which is already executing in the processor, P1 just now entered at the 2 unit of time, the shortest job will be compared. Still, P4 has completed 2 units of its. P4 has completed 2 units already at the 2 unit of time. Still, P4 is having 1 unit to complete its execution, right? So still P4 is having 1 unit. Now P1 enters and tries to acquire the processor. But what is the shortest job? Which one is the shortest job? P4 or P1? P1 is 6 unit of time it is taking. So P1 will be in the waiting only, right? Shortest job is P4 only because it's still 1 unit of time is left out for execution, complete its execution. So 1 unit is still left out. So P4 will continue as usual. Okay. At 3 unit of time, when at the 3 unit of time, any other process tries to enter at the 3rd unit of time? 3 unit of time? No. 0, 1, 2, 4, 5. No other process is entering. Now, at at the third unit of time, P4 has completed its execution, right? P4 takes 3 unit of time, so at 3 unit of time, P4 completes its execution, right? So P4 will be printed out. It has completed, it will come out. Right now, another process will be entering into the processor to get executed, right? At the 3 unit of time, what processes are already in the waiting? 3 unit of time, P1 and P3 are in waiting to acquire the processor, right? No other processes enter at the third unit of time. Only processes are P1 and P3, right? Right now, SJF will be implemented, right? So which one is the shortest job? That will be compared, and that process will be acquiring the processor, right? P1 and P3, which one is the shortest job? P1 and P3, okay? P1 is 6 unit of time, P3 is taking 8 unit of time. So which one is the shortest job? P1. So P1 will be acquiring the processor, right? So P1 will be entering into the processor. So P1 enters, starts executing, right? So at the 4th unit of time, when P1 has executed 1 unit, at the 4th unit of time, any other process is tries to enter into the processor? Yes. At the 4th unit of time, P5 enters into the processor. Okay. Right now, the exact game starts. Okay. Right now, P1 has acquired the processor, right? At the 4th unit of time, P5 enters. Now P1 has already completed 1 unit of execution. Still 5 unit is left out for completing its execution. Try to understand the concept, right? Still 5 unit is left out for completing its execution. So at the 4th unit of time, when P5 has entered into the processor, now which one is the shortest job? Which one is the shortest process to complete its execution? That will be compared. Shortest job first. Okay? P1 is still 5 is left. Still 5. P5 is having 4. P3 is having 8. Which one is the shortest now? When P1 has completed 1 unit, 5 or 4 or 8. P5 is 4, P3 is 8, and P1 which is inside the processor is 5. Still 5 left, right? Which process will be executing right now at the 4th unit of time? At the 4th unit of time, P1 will be printed out. Right? At the 4th unit of time, P1 will be printed out, and which will be acquiring the processor? P5 will be acquiring the processor because its execution time is 4. It is the shortest job, and it is a preemptive SJF. Don't forget that, right? It's a preemptive SJF. Right? Which one will be shortest? That will be getting the processor. Okay? P5 is shortest right now. 4, 8, 5. Which one is shortest? P5. So P5 will be acquiring the processor. Okay? Right now, P5 starts executing. P1 has been printed out. P1 has completed 1 unit of execution. Still 5 unit of execution is left out, right? So P1 will be in the waiting state right now. It has printed out and gone to the waiting state. And remember that P1 has already completed 1 unit of time. Still 5 unit of time is still left for its execution, full execution, right? Now P5 start executing. when P5 start executing, 4 unit of 4, its arrival time is 4, right? At the 4th time, P5 starts execution. Okay, so at the P5 starts executing, right? So P5 enters at the time 4. Okay, P5 enters at the time 4. It is the starting time of P5. Okay, so it will start executing. So at the time interval 5, any other process are there which wants to get entered into the processor? Yes. At the time interval 5, the process P2 wants to enter into the processor. So P2 will be entering into the processor and it will be in waiting state. Okay. So right now P5 has started its execution and it has completed its 1 unit of time. Okay. So P5 total execution time for P5 is 4 unit. Okay, so it has completed its 1 unit of time, and when it completed its 1 unit of time, that means when the time has reached 5, one more process has already entered into the processor, that is P2. Right? Understanding? Okay. At time 5, right now the SJF algorithm gets implemented. Okay, that means which one is the shortest job, that job will be acquiring the processor, right? So at time 5, when P5 has already completed 1 unit and the left unit is 3 units of time is still there for completing the execution of process P5, still 3 unit is there. Okay, so at this point of time, when another process has entered, right now the comparison of the shortest job will happen. Okay, so try to understand. Right now the comparison of shortest job will happen. Right now all the processes have acquired the processor, right? All the processes are inside the processor and they are in the waiting state. Okay, to acquire the processor for execution, right? So P1, P2, P3, P4, P5, everyone is inside the processor, and whoever are executing, they are executing. Whoever are waiting state, they are in waiting state. Okay, understanding? So when P5 has completed 1 unit of execution, P2 enters. Now the comparison of the execution time will happen according to SJF, shortest job first. Okay, right now at 5 unit of time it will be compared. So how many P2 is having what is the total execution time? P2 is having 2 units of time. P1 is having how much? 5 units are left out, right? Then P5 3 units. Then P4 it has completed its execution. P4 has already completed its execution, right? Next P3 8 units of time is required for completing its execution. Right now, which one is the shortest job? Right now, which one is the shortest job? The shortest job is 5, 2, 8 or 3. P1 or P2 or P3 or P5. 4 has completed already, right? So now the shortest job is P2. Try to understand. Now the shortest job is P2. So right now the P2 will be acquiring the processor for execution because it is the shortest job. So what happens? P5 will be preempted out. Preempted out. So P5 will be preempted out and it will be again going and in the waiting state, right? So remember that it has already completed 1 unit of time of execution. 1 unit of time has already completed, 3 units are left out. At that point it will be preempted out. Now at 5 unit of time, which process will acquire? because it is the shortest job, right? So P2 will be acquiring the processor at the 5 unit of time. Okay. So P2, what is the total execution time for P2? 2 units of time. So any other processes are there outside the processor which wants to enter into the processor and be in the waiting state? No other processes are there, because only 5 processes are there and they have already entered into the processor and they are scheduled by the CPU scheduler in the waiting state, right? P2 enters, no comparing right now, it will execute till its completion, right? So it will execute its 2 units of time, that means 6, 7. So at 7, the P2 execution is completed, right? Understood? Right now, P2 has completed its execution, okay? So right now, at the 7th unit of time, again, the which process will be acquiring the processor right now, okay? Because P2 completed, it printed out, right? So right now, which one is the shortest job according to SJF? That will be chosen, right? So which one is the shortest job? P2 has completed its execution, right? Which one is left out? P1, P3 and P5. So out of P1, P1 is 5 units, P3 is 8 units and P5 is 3 units. So which one is the shortest job? The shortest job right now is the P5. Understood? So right now the process P5 will be acquiring the processor. Okay, are you understanding? So P5 will be taking how much of time right now? 3 units are left out. Okay, so 7, 8, 9, 10. So at 10 unit of time, P5 completes execution. Okay, 7, 8, 9, 10. Right? So right now, P5 has completed. So right now, which process will be acquiring? Which one is the shortest? The process P1 is the shortest one. Okay, so process P1 will be acquiring the processor. Okay, so how much time it is taking right now? 5 units of time. Okay, so 10, 11, 12, 13, 14, 15. Okay, so at 15, the P1 completes its execution. Right? Now, P1 completes, is printed out. Execution completed. Right? So which one is the last job left out? P3. Right? So it acquires the processor and it starts executing. Okay? So how much time it is taking? 8 units of time. So 15, 8 units, right? 1, 2, 3, 4, 5, 6, 7, 8. So 16, 17, 18, 19, 20, 21, 22, 23. Okay. So at 23 unit of time, the overall program gets executed. Okay. So finally, all the processes has been executed. Okay. All the processes has been executed. Right. So right now, what is the waiting time for individual processes? P1, P2, P3, P4, P5, right? So what is the waiting time for process P1? What is the waiting time for process P1? P1, so you can see here process P1 starts executing here, starts executing at 3 unit of time. Okay, so P4 has completed, then P1 enters, right? So P1 enters and starts executing. What is the arrival time for P1? 2. So what is the waiting, total waiting? It starts at 3, arrives at 2. So waiting is 3 minus 2 is equal to 1. So waiting here 1, but P1 has still not completed its execution. It has printed out. After completing its 1 unit of time, it takes how much total? 6 unit of time. So it has completed 1 unit and printed out. And later on, it gets the processor over here. So how much after printing out? 1 unit completed. At 4 it has completed. So again it is acquiring at 10. So what is the total waiting time for P1? Are you getting? 4, 5, 6, 7, 8, 9, 10. 6 unit of time. Again the P1 is waiting. Second time. Okay. So in the first it was waiting for 1. Second time it is waiting for 6. So 6 plus 1 is equal to 7 unit of time P1 has waited for the processor to acquire. Okay, understood? Right now, process P2. So what is the total waiting time for the process P2? So see here, the P2 starts execution at what time? At 5 unit of time. Okay? P2. So what is its arrival time? At the 5 only. And does it complete its execution? 2 units? Yes. 5, 6, 7. It is completing, right? So what is the total waiting time for P2? 5. As it is arriving at 5. So no waiting. So 5 minus 5 is equal to 0 unit. No waiting. Once it entered into the processor, it got the processor, it started executing, and it has completed 2 units of execution time also. Okay? So no waiting for P2. So what is the waiting time for P3? So P3 starts execution over here, right? At the 15 unit of time, P3 starts execution, right? So at the 15 unit of time, P3 starts execution. So what is this arrival time? P3 arrives at 1 unit of time minus 1. So P3 has waited for 14 unit of time. Understood? Next, P4. What is the waiting time for P4? See, P4 has entered into the processor in the starting at the 0th time, and it has completed at the 3 unit of time. No processor was there, no processes were there to get compared according to SJF, and it has completed its execution at 3 unit of time. As it is taking 3 unit of time for total execution, right? So it has completed. In the beginning itself, it has completed its execution. So what is the total waiting time for P4? 0 only, right? So 0 minus 0 is equal to 0. Understood? Next. What is the waiting time for P5? So P5, so here it has entered, right? At the time 4, it has entered, P5. And it started executing. It started executing and it got printed out after 1 unit. That means 4 to 5 only it has executed, P5. So total execution is 4 unit of time. Only 1 unit has executed here. Then it got printed out. So what is the waiting here? Waiting time. So it started at 4. What is its arrival time? 4 minus 4? 0. Okay. So 4 minus 4, it is 0 here, right? So it has completed. Started at 4, arrives at 4, starts at 4, completes 1 unit only. Out of 4 time, it completes only 1 time. Still 3 time is left out, right? So it is printed out, now it is in waiting. From here it is waiting. So when it acquires again at 7. At 7 unit it acquires the processor. So how much it is waiting right now? 5. It was printed out at 5 and P2 entered, right? So P5 is waiting now. It occurs again at 7. So what is the total waiting time? 5, 7. So 7 minus 5, only 2 units it is waiting. So it occurs at 7. So 7 minus 5. Okay? 2 units it is waiting. Right? So total is 2 units. 2 units of time it is waiting. So 0 plus 2, it is 2 units of time. P5 is totally waiting for the processor. Right? So right now, what is the average waiting time? Average waiting time. What is the average waiting time? 7 plus 0 plus 14 plus 0 plus 2 divided by how many processes? 5. Okay? So how much it comes? 14 23 by 5. So how much? 4.6 unit of time. Total average waiting time for all the processes is 4.6 units of time. Okay? So I hope you understood the preemptive SJF, the very important algorithm. Okay? So such kind of algorithm is very useful in batch sharing systems. Okay, so mostly it is used in batch sharing systems, and I hope you understood the preemptive SJF. Okay, so we have covered the non-preemptive SJF in previous video. So here I have covered the preemptive SJF. So I hope you understood the preemptive SJF. In the next class, I will discuss about the priority scheduling algorithm and also the round robin scheduling algorithm. Okay. So for the time being, I am stopping here. Okay. So have a nice day. Thank you. Namaste.